Good morning, chemistry students. Today's lesson is on the effect of both pressure and temperature on phase changes. The learning target is I can predict the effects of pressure and or temperature changes to a substance's state of matter. So we'll integrate a lot of vocabulary here. Not just the states of matter, whether it's solid, liquid, or gas, but all the phase change vocabulary we've been working on as well. Boiling, condensation, freezing, melting, sublimation, deposition. The complicated part about this, so far, we've really only talked about temperature. The addition of pressure changes things. It's not very intuitive to us, especially if you've lived in one place all your life. You're not used to seeing these pressure changes. And if you do, they're invisible pressure changes that happen as storms move in and out. You're not as aware of these pressure changes. The most common pressure that we're under the influence of here is the pressure of the atmosphere on top of our head. We in Cape Cod are living at sea level. So we have one entire atmosphere on top of our head. You can see that in the y-axis down here. Pressure can be measured in ATMs or atmospheres. Sea level is one atmosphere of pressure. So let's look at this graph and intuit some things about it. We've got pressure on the y, temperature in Celsius on the x. We've got a substance so far labeled C, B, and A. Same substance, three different states of matter. What I want you to be able to do is, even if I don't tell you what state of matter it is, that you'll be able to know which state of matter is which. The easiest thing to do here, to figure that out, to orient yourself to this, is pick a pressure, let's just say 30, and drag a line across. So at 30 atmospheres of pressure, we have this zone where there is a low temperature, a medium temperature, and a high temperature at that pressure. Now you should be able to know which state of matter is which. At the highest temperature of a given pressure, so this entire zone of A, that entire zone of A, we would call a gas, right? Highest temperatures, no matter what the pressure is, highest temperature is typically going to be a gas. This next zone that is in that medium temperature at the same pressure, so this zone all in the middle, that's going to be our liquid. And when temperatures get to be their lowest temperature at a given pressure, you are typically going to have your solid state of matter. All right, so no matter what the shape is, they will be different. They're always going to have this kind of characteristic Y-looking intersection of lines, but the shape and perspective and slopes may be different. Let's look at how we can pull some more data out of a graph like this. First thing you could do is you would be able to find the melting and boiling points of a substance at a given pressure. So given pressure is key here. You have to know what the pressure is. In the example down below, you can see for 1 atmosphere of pressure, sea level, the melting and boiling point. All right, so what do you have to do? Find the pressure on the y-axis. So they already have that marked out here. At 1 atmosphere of pressure, drag a horizontal line across if there's not already one there. And then where you see the transition from solid to liquid, you pull a horizontal line going straight down. Where you see the transition from liquid to gas, you pull a horizontal line straight down. Boiling points and melting points are measured in degrees Celsius, so we need the number off the x-axis. And you can see they've already estimated those on here. 209. You can see that's this first line, that line that was from the transition between liquid and solid, your melting. is right below that 210 mark. And then you can see they've also put the negative 195, and that's ish. It's not the best graph for being able to read numbers, but that looks like, yeah, right about 196, 197, 198 if my eyeballs were totally guessing and I didn't have those numbers in front of me. Let's do another one. So melting point, boiling point. Let's say they wanted at 10 atmospheres of pressure. So I'll take 10 atmospheres, I'll pull a horizontal line across. I will find that transition between solid and liquid. This is where melting will occur, or freezing if you're going the other direction, and pull a vertical line down. Find the transition between liquid and gas, and pull a vertical line down. And then you'll go ahead and estimate those. So for these new ones, right there and right there, the melting point, solid to liquid, for the same substance at 10 atmospheres of pressure, looks like it's probably 197, 198, maybe around negative 200 degrees Celsius. Negative 200 degrees Celsius is the melting point. For the boiling point, I'll abbreviate BP, that looks like maybe negative 173 or so degrees Celsius. If you want another one you can do on your own, go ahead and see what you think for about 5 atmospheres of pressure. All right, give that a try. Determining the state of matter at a given temperature and pressure. Find the pressure. So, what is the state of matter? Let me erase all the work that I've got on here. So, state of matter at a given temperature and pressure. Find the pressure on the y-axis, find the temperature on the x-axis. Draw intersecting lines. All right, so what if the question said, what is the state of matter at 10 atmospheres of pressure and negative 230? So 10 atmospheres of pressure, I find that on the y, and I put a horizontal line. Negative 230, and I draw a vertical line. Right here in the middle is the scenario of a given pressure, 10 atmospheres of pressure, and a given temperature, negative 230 degrees Celsius. And this would be in the zone that we would consider solid. What if instead we said 99 atmospheres of pressure and negative 175. Notice I've got a little cheat with my pen and an electric device so that it's actually horizontal. Make sure you're using a ruler and you'll get much more accurate information. If the pressure was 99 atmospheres and negative 175 degrees Celsius, then I would say the substance is a liquid. Last thing you can do from this, determine what would happen if. So now you're merging these ideas together. Knowing when boiling, melting, freezing, condensing, or even sublimation deposition would occur, then you can tell this story. So, determine what would happen if. Let's say we started at negative 230 degrees Celsius. So we're again here. You already told me that's a solid. What would happen if you increased the pressure increase the temperature by 55 degrees Celsius. All right, so if we increase the temperature by 55 degrees Celsius, we travel the red line. So to describe what would happen, I'd say, well, it would start as a solid. It would transition from solid to liquid. And you would use good vocabulary and say that would be melting. Once it reached negative 175 degrees Celsius, it would be a liquid. Now, two stories could occur here. I could say, all right, what would happen if you now increase the pressure by 89 degrees? So now you're traveling up this line to that original orange that we had. You'd say the substance would still be a liquid. Alternatively, we could say, just to make the story more interesting, what would happen if you decreased the pressure by, let's say, 9 atmospheres of pressure? Well, you first said it was a solid. It then melted into a liquid. Now you would say that liquid would boil or vaporize into a gas. Other key terms in order to do all of those, make sure you know all of the different phase changes. Solid to liquid, liquid to solid. Liquid to gas, gas to liquid. Solid to gas, gas back to solid. Make sure you can identify these as melting, vaporization or boiling, condensation or condensing, freezing, sublimation, or deposition. All right. If you need a review on those topics, go back to the lesson on phase changes to refresh your vocab on phase changes between the different states of matter. Turn to the last page and go ahead and try and solve these. You've got a little bit of all of them. If you need help remembering how to do them, just come back to these steps. 1, 2, 3. Boiling point and melting point at given pressures. States of matter. And merging the two ideas together to tell a story. Good luck.